This episode of Serverless Chats is sponsored by Epsagon. This week, I chat with Tim Suchanek about serverless and TypeScript. This is Serverless Chats, episode number 83. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today I'm speaking with Tim Suchanek. Hey Tim, thanks for joining me.
Thanks for having me, Jeremy.
So you are a TypeScript lead at Prisma. So why don't you tell the listeners a little bit about your background and what Prisma does?
Yeah, so first of all, thanks for having me. It's an honor to be here. I have listened to several episodes already. And at Prisma is basically a database tooling company, you could say, where our core is implemented as open source. So everything we build is available for everyone, and everyone can contribute. And what we basically focus on right now is a database client, database access, but we're also working on schema migrations. And what this database client is doing is mostly giving you type-safe access to your database, and we do that in TypeScript. So the way Prisma is architectured, we can also implement clients in different languages like Go or Java. We have the core of the query engine is written in Rust, and TypeScript is basically a layer on top to give you type safety for your database. And with type safety, I mean, if you, for example, say, I want to select a certain field, then you will also, in your types, in your code, will have the guarantee that this field will be there. And I believe that still, until today, this is the only client out there giving you really this kind of experience. And how this works is through code generation. So we employ code generation quite heavily. And you define declaratively your schema. You say, I have a user has a post, and so on, or has posts. And based on this schema definition, we then generate the whole client in TypeScript. And this is now in GA for since 2020. We have been working on this for 2 years, and in general, Prisma already exists for nearly 5 years. So yeah, that's what we're doing. And obviously, if you use your database, you oftentimes in 2020, you use serverless. And so we see many users, we see a lot of adoption rising there, while still many users are using this in a containerized fashion. We see a big growth also how this is being used in Lambda and serverless. Yeah.
And what about your background? How did you get into TypeScript?
So it's funny because I started JavaScript, I think 9 years ago, and did not really, besides having had typed languages in uni like Haskell and Java, the usual stuff we had to look into. Besides that, I was really into dynamically typed languages. Not really a big fan of anything like, the type system was my enemy, basically. And TypeScript came around 2015. I had the first look into it. Actually, Johannes, who's the founder of Prisma, he made me aware of it, that TypeScript even exists. So I looked into it, and first I had, I would say, quite strong resistance to it, because once it feels a little bit like it's taking away your freedom. I'm so free in JavaScript, I can just do what I want. And but if you are looking a bit more into it, if you're reflecting a bit and thinking, okay, where can this really help me? You are step by step understanding that the compiler is not your enemy, but your friend, and just really protects you from your own stupidity, basically. Doing like, we're just humans, and it doesn't matter how good of a programmer you are, you will do these mistakes, and TypeScript really helps. So since 2015, I have not used anything else anymore. And here I really have to cite a colleague, Ryan from Prisma, recently tweeted, like, if he is not writing code in TypeScript anymore, it feels like going outside without clothes. So it's really like something is missing. It's like the safety net, the safety layer is somehow missing. So I am basically someone who converted from JavaScript is my religion to now TypeScript is it. And both in Node and in the front end, I'm now using it for 5 years. Yeah.
Awesome. Well, I've been programming in JavaScript for 23 years. So it
Okay.
is yeah, so it was a very difficult change for me. It was a huge mind shift for me. But anyways, all right. I don't typically fool my listeners here, but I think we're going to fool them a little bit because even though this is a serverless podcast, we're going to talk a lot more about TypeScript. And of course, we're going to link it back to serverless here, but and maybe we'll start that in the beginning. But there are so many really, really cool things that you can do with TypeScript. If you're building serverless applications, it's going to help you. And I'd like to start by maybe just getting your thoughts on why TypeScript is going to be an important thing for serverless.
Yeah, so I just checked the stats. So New Relic just released a report about how much like which runtime is used in serverless most, where they are where the New Relic product is activated, and over 50% is using Node of the Lambda runtimes. So it's clear Node is the majority here. And I would now claim if you do Node, you should do TypeScript. So it's quite relevant to say most of them are using Node, and in Node, instead of having it untyped in JavaScript, I think it's really useful to use a TypeScript. And now is the question really, why is that so useful? Why should you do that? And so maybe a quick introduction again, or reminder, what is TypeScript? Rather a reminder because I think most of the people know it already or know that it exists. There was the State of JS report 2019 where they asked like, did you ever hear about TypeScript? 58% heard about it and want to use it again. And I think only less than 1% haven't heard about it yet. So I guess most people have heard about it. But the question is really, what is it? And I would say you can define TypeScript as a superset of JavaScript. So the JavaScript syntax, what you can express with JavaScript is a subset. So that means everything you can do in JavaScript, you can also do in TypeScript. That was one of the goals upfront when they designed TypeScript. You need to be able to, in hindsight, be able to type any program you have written in JavaScript with TypeScript. You need to be able to put the types on top. And so why is this so interesting now? Once you have these types defined, this helps users to explore your API. It enables auto-completion. It helps you with documentation. You can add comments. So JSDoc and TypeScript types are really working well together. You can do both together, and I even recommend doing both. So you don't just type things, but you can on top add nice comments in JSDoc. They work well together. And after all, if you use VS Code, I guess also many developers are using VS Code these days. The VS Code JavaScript language service is maintained by the TypeScript team. So this is one thing, because again, it's a subset of it. And if you are using JavaScript today, chances are very high that you already experience auto-completion or an enhanced developer experience enabled by TypeScript, although your code is not written in TypeScript. So I think the main point is really developer experience and also giving you safety. So if you look into the whole serverless world, then you oftentimes deal with APIs, third-party APIs. Let's say we're dealing with the AWS SDK. And I mean, it's huge. The AWS SDK, it's impossible to know everything. And it's also sometimes hard to find exactly what you want in the docs and in examples. And in that case, the types are really helpful. I recently looked into TimeStream-DB, the new serverless time series database from AWS, which became GA a couple of weeks ago. And because it is so new, there was not so much content around yet. So I just checked out the types of the AWS SDK, and that really helped me to understand some more like edge cases, details of the API, what is even available. Maybe they didn't document it. So I, these days, even use types oftentimes to explore an API.
Yeah, no, I totally agree with exploring the APIs, because The problem with AWS documentation is it's often very complete, but you have to keep digging and digging and digging to find sometimes the right thing that you need, and just to have it pop up and tell you what methods are available or whatever. And the other thing is with the JS doc stuff, that is something that I've actually been working on another library that I'm trying to add all the JS doc stuff into, as well as converting it to TypeScript, completely to TypeScript, which we can talk about in a second. But I found that is really, really helpful way for you to do. It almost forces you to do documentation on your own code. So you document your own methods and things like that. But then when that is converted, when it's converted to types, it helps with the, just from the user perspective, and gives you that really, really good developer experience. So let's talk about third-party modules for a second. So the idea of writing something in JavaScript. Now, this is something I did for a long time. I was writing NPM packages in JavaScript, and this was, sort of early days of TypeScript. So TypeScript was not super popular at that point. But then people are coming along like, oh, do you have the TypeScript types for this? And I was like, no, I don't, whatever. And people were then like, oh, I'll contribute it. So they added these TypeScript types, the type definition files, which are great, right? But if you look at the type definition file and then you go and you look at the actual code, anytime you make a change to your code, you have to say to yourself, oh, wait a minute, do I have to update the types now? And so one thing that I've started to do is convert some of my projects over to TypeScript directly because, one, it's very, very helpful just to have that capability there. And again, a lot of my services interact with AWS, so being able to use the the autocomplete for those is good. But what's your suggestion for people who have written applications or written modules and packages in JavaScript? Like, how big of a motivation is it for them to convert those over to TypeScript?
So the beauty of TypeScript is that you can adopt it incrementally. And by the way, here I want to also point a little bit to Flow. Back in the days, 2015-16, it was not clear who's the winner. Flow from Facebook and TypeScript from Microsoft both wanted to solve the same problem. Want to make JavaScript a bit more safe, and if you have huge code bases, you're happy to have something like that. And in the early days, that was one of the advantages of Flow, the incremental adoption. You could easily have JavaScript files and TypeScript files in the same project. That was not originally so easy in TypeScript. However, later they added the allow.js flag to the TypeScript config, and with that you can basically start turning file by file into a TypeScript. And also you can make the type checks very loose, so to say. You can start with an any type, and then you step by step introduce types. And I think with that you can introduce it quite easily. What most developers, I guess even in Node.js, already have is some kind of compile step. If they don't, yes, you now need to introduce a compile step. Because you just run the TSC command basically, which takes all of your input, and it just it's a little bit a bundler. Not really a bundler, it's rather transpiling. Just that if you, for example, use generators, if you use promises, async functions, and you want to turn that into ES5, then you may need to transpile that. So TypeScript is at the same time basically covering Babel. So oftentimes, if you have Babel in your project, probably you don't need that anymore if you switch to TypeScript. So TypeScript, the compilers, for example, also able to parse React, like JSX syntax. So I think oftentimes it's like getting this compiler into your build pipeline is probably not the biggest thing. And especially if you start with like file by file, the TypeScript compiler will be very fast in the beginning. It can get a bit slower later if you have really, really big projects, and also depending on how you define the types, how much like advanced TypeScript stuff you do, because somewhere the compiler needs to run something somewhere. But overall, I suggest really directly starting to introduce the compiler in your code base and file by file convert that over to TypeScript. Yeah.
Yeah, and I've found that with TypeScript, trying to trying to incrementally add it. The any thing works out really great. The problem, though, that I've had is I always thought a lot of what I was doing in JavaScript were these nice little elegant, like, maps or, a lot of ternary operators in there, like just things that made the code seem really, really clean to me. And found it very, very difficult to add types to some of those. Like, it almost forces me to rewrite things to if statements and make things for loops, make things a little bit easier and a little bit clearer. But I feel like it makes me write more code sometimes, which is fine.
Mhm.
But I think it probably makes it clearer and almost enforces some standards that you kind of have to follow.
Yeah, and a typical example where I really have to say that TypeScript improved my code quality is when you do like duck typing or you need to check, is that a specific type? So
Right.
let's say, I don't know, if this type that I get could be an object or a string. In JavaScript APIs, you have that oftentimes, right? And what I used to do more is that I just do it inline. Maybe a ternary statement, just check, is it a string, then do this, otherwise that. And
Right.
with TypeScript, you have a specific keyword built into the language that is. The keyword is called is. And with that, you can have, let's say, a function that returns if that is indeed that type or not. So that means, so it returns a Boolean, but it has a special meaning now, semantic meaning in the types, because you now can do your if statement. Let's say it is a car. And if this if statement is true, TypeScript knows that everything you do in that if block is definitely accessing a car. And this way you really you can make this connection between runtime and compile time, because the reality is you not always know the type of it. You need to sometimes validate user input or input from other APIs. And this is a very useful way to discriminate the types. And putting that into a separate function alone already, is it a blah, blah, blah type? These kind of patterns, it's not possible to do that without a function in TypeScript. Like TypeScript really forces you need to put it into a separate function. That function has this specific return type that is, and then the type car or something else, and that way you can clearly separate that. Now, writing these functions is still a bit tricky. Actually, yesterday we did a new meetup format at Prisma called Advanced TypeScript Trickery, because we recently saw like more and more crazy stuff popping up at Twitter. We can also later like geek a bit out and talk a bit more about like the crazy new stuff that TypeScript enables. And someone talked about like he really uses the is keyword a lot, and talked about how you in practice really implement that function, and found out that what you just mentioned with, okay, I have JavaScript code here, I have my declarations, TypeScript declarations, how do I make sure they match? That is still a problem in the is function. That's not yet solved properly. However, we have great libraries for that. One of them is called IOTS. And there you can basically define a TypeScript type in runtime. So you get like a programmatic API. You can say T dot and then string, and you can like construct and nest your types. And that gives you both, it will give you a valid TypeScript type. It will make a valid TypeScript type for the compile time, but also gives you a runtime checker. So you basically take the whole TypeScript compile time checking into runtime. And if you now get a input and you don't know, is it a car, you can use one of these libraries, IOTS, which are really useful for validation here, to validate if things are proper. And if you look at the whole validation space in general, is really exciting what is changing there. If you look into the libraries that people used to use, like Yup, for example, some people may be familiar with that. They, in hindsight, added the TypeScript on top, which works reasonably well. But now we have TypeScript native libraries coming. Zod is one of them, IOTS, and they give you the full package, because obviously it's awesome if you can already validate in compile time, if possible. And then later in your code, once you have run this check from the library IOTS, you have the guarantee in your code, yes, this object has these properties. You don't need to write any code there anymore.
Right, which is interesting because and maybe we can move on to the project you and I sort of first got connected on, which is the DynamoDB toolbox.
Yeah.
So this I spent probably, I don't know, 80% of my time coding on writing runtime checks for the data, right? Make sure that this
Yep.
particular that when you pass in options, that this particular option is a valid option, and then making sure that the type and so forth. And I had thought about maybe using Joy to do that, or is it pronounced Joy, Joi, or whatever it is.
Yeah,
But then I
yeah,
was
yeah,
like,
yeah.
that just seems like a lot of extra work, and I'm basically doing the same thing, and some of them don't need to be as complex. So that is something that would be really, really cool to have, is to simply say, how do I take my TypeScript checks and bring those onto the runtime to enforce them on that side. And I mean, maybe we can just before we get into the DynamoDB for a second, maybe we can, or DynamoDB toolbox, we can take a second and talk about something like Deno, right? Like some of these runtime for TypeScript things, because those seem really promising. But what are your thoughts on those sort of things? Because I know there's some performance issues.
Yes, I mean, Deno is a really exciting project. It's really awesome. And we are also getting more and more requests now at Prisma to add Deno support. We don't have it yet because we use the child process API quite extensively, and that's just a little bit different, like the process model in Deno. But we get more and more requests. I still didn't get an answer from anyone because we asked, do you use it in production? Not that many answers yet, but I think it's coming. And that is definitely quite expensive to see. If you run the TypeScript compiler, and also a few weeks ago at the TypeScript conference, I gave a talk about pushing it was a bit a catchy title, pushing the compiler to the limit. And it was
Right.
both in terms of complexity, but also in terms of quantity of how many types we are even having in there. And that performance is an issue if you have really big projects. I think that is also for sure a little bit detrimental in the beginning, at least for Deno, because they need to do all of these type checks. But I think help is coming. So what is really exciting, if you see, for example, the project ESBuild by Evan from Figma. So it's basically a, let's say, Babel alternative written in Go. And it's just I think 100 times faster than anything in JavaScript. And now there's this project called SWC, I think. It's written in Rust. And they already are able to compile TypeScript, which makes it already 20 times faster or really much, much faster than the TypeScript compiler, which is self-serving, by the way. It's written in TypeScript, which is good. It's a good indicator that it's a proper language. I think Anders Hallsberg, the founder of TypeScript, is proud of it. But now they are really looking to move this to Rust, which is hardcore. If you look into the compiler code, I used to contribute a few little things. It's crazy. You have one file, 20,000 lines, and that is only Anders Hallsberg, who came up with C# and Delphi. He's the only guy who's allowed to touch that file in the TypeScript team. So it's really you need to have this extreme context in your head to be able to work on that. And I even heard from someone who did an internship at Microsoft that they wanted to move the TypeScript compiler. It was an internal experiment at Microsoft. They wanted to move it, I think, to .NET. There is still some artifact on GitHub somewhere of that experiment, but they gave up. They realized this thing is too complex. And also, I mean, there are for sure type systems where just said we stop. We don't do any generics like Go. They kept it simple. TypeScript, they are just going hardcore on the features. It's insane what kind of features they have. They have sometimes features that even Haskell doesn't have, and Haskell is one of the most powerful type systems. So it will be a challenge to move that over to Rust. But coming back to Deno, I think Deno is a really exciting project, and also having not to deal with the overhead of adding TypeScript, it's beautiful because you can just write it and you don't need to deal with the extra compile step anymore. And in practice, I also have to say the compile step is not really a problem for me anymore because I'm 99% of the time using TS Node, which is just a little CLI utility that injects the so in Node.js you can override the require system, And what they do, they overwrite. If you require a TypeScript file, they quickly transpile it and then they run it basically. And that's what TS Node is doing. And that way you can directly say TS Node, then the TypeScript file, and you can just run it. So you don't really need to care about this extra transpilation step all the time.
Hi everyone, I want to take a minute to thank our sponsor, Epsagon. Epsagon enables teams to instantly simplify, visualize, and understand what's happening with their complex microservice architectures. With their comprehensive, lightweight auto-instrumentation, users are able to eliminate the gaps in data and manual work associated with other APM solutions, providing significant reduction in issue detection, troubleshooting, and resolution times. Epsagon aggregates and correlates data from all the third-party tools you love, delivering a single pane of glass for understanding serverless, containers, Kubernetes, and more. Engineers now know when something is wrong and can immediately trace issues to root cause before they affect production, increase development efficiency, and reduce application downtime with Epsagon. As a special for Serverless Chats listeners, if you try out Epsagon and connect your first trace today, they'll hook you up with one of their awesome t-shirts. Check it out at epsagon.com/serverlesschats.
So the way I found you, by the way, I was building this DynamoDB toolbox library. I've been building this for over a year now. And I had a lot of people saying, well, we got to move to TypeScript, And I said, you know what, you're right. This is the time we're going to do it. I spent several weeks porting this thing over to TypeScript. And the biggest challenge, though, was that what I wanted to be able to do was I wanted people to be able to define their schema for entities in a DynamoDB table, and then be able to have that autocomplete basically for them when they got returns from whatever operation they did. So whether it was a get or a query or something like that. And so the way that I sort of figured out this could be possible was, well, you could have them define their own type. If they're building in TypeScript, have them define their own type or schema and pass that into the library, and then that would carry that through. But essentially, they would have to do that twice. They'd have to define their the structure, define the schema for a particular item, and then they would have to write a TypeScript interface or something on top of that would allow them to basically retype it or add types to that, whatever. And I was like, that just seems like a lot of work. So I went down this rabbit hole, and I came across a talk that you did called Generics, Conditional Types, and Map Types, which was absolutely fascinating. So what I'd love to do is just quickly tell me or tell the audience what it was you talked about in that type in terms of what you were building for Prisma.
Yeah, so it's nice to see that you came across that, because that was just like, I think we started the TypeScript meetup back then, and then we just said, hey, let's put in some talk that, let's say, talks a little bit more about advanced concepts in TypeScript. And it's funny, like the definition of advanced also changes, because yesterday again we had this advanced meetup. It seemed like what I'm doing is like totally basic, and now I'm seeing what other people is doing is more crazy. So this situation that you just described, that you don't want users to do definition in JavaScript and in TypeScript on top, or like two definitions of their types of their schema that they need to keep in sync, that is exactly the same problem that we have with Prisma. So Prisma client is again, it's defined. You define your schema in a DSL that we came up with at Prisma. We call it the Prisma definition language, and it's for the people. I think it's actually quite similar to a TypeScript definition, or for the people who use GraphQL. It's similar to a GraphQL SDL schema definition language definition. So you basically can just say, I have a model user, and then you can point to another model, and you can command click it in VS Code, and you have this nice experience. And that is how you define the whole schema, how you define relations. And then under the hood, you have a CLI that's also written in TypeScript, and that generates the whole Prisma client implementation basically for your particular schema. So all the capabilities it has: create, read, update, delete. Maybe you have a JSON column in there, and so we give you a specific JSON filter. So all of this is generated depending on your schema, on your database that you use. We support SQLite, MySQL, Postgres, MariaDB, and MS SQL. MongoDB is coming, but it's still, MongoDB is a completely separate paradigm because it's NoSQL. Right now, the SQL databases is still like more feasible to support them. And so what we were looking into is like, how can we reduce the amount of code generation in order to give people a nicer developer experience, but still have the type safety, and in particular about querying data. So let's say I only want the ID. How can I achieve that in a type-safe manner? You could say you, for example, have let's just build our own database client now. You could have a folder that is called queries, and you could have a file there that you call the user ID query.json, and then you just have a JSON definition of that, of what you want, and then you would run a CLI that looks into that and that generates the types or generates like what is available, and then in your code you know, I have the ID available. But how about you could skip this step of extra generation? How about you can build that into the type system? And that is what we did with Prisma Client. So depending on the object, which is like the query that you write with Prisma Client is just a JSON object. How about we can, depending on the shape of that object, have different types for the output of the query function. So in other words, if I'm adding to that object now the name field as well, then suddenly I have this available in the return type of this function, let's say Prisma user.query, for example. And this would be really awesome if that is possible. So we looked into that topic last year, January, and we knew there is a mechanism in TypeScript that might make this possible, but we didn't know if that's actually possible. And this mechanism is called conditional types. And the conditional type really says, some languages also call it dependent types. There are not many languages, first of all, which have such a concept. I think C# has it, Haskell has it. So the idea is really that you say, depending on the input I have a different kind of output. So you use generics in that case. A generic is, I think, I just refer to it as a variable on the type system. And you can say, let's say, if the input is a number, the output will be a string. And if the input is a string, the output will be a number. Not sure if that function makes sense, but this kind of combination you can do. So you can not just say if the input is a string, the output is a string. That you can oftentimes do with generics, or you can pack, let's say, an array around it. You really can say, you can provide more, let's say, complex conditions. And so we looked into that topic. And another important ingredient to be able to implement such an API that maps like the input to a specific different kind of output are map types. So TypeScript has so-called structural typing, and that means you can define types just by defining a certain structure of the type, and the structure can be, let's say, an object type, for example. In JavaScript, if you have an object has keys and values. So now in object type in TypeScript, you can say what keys are allowed and what values are allowed. So only these certain 3 keys, let's say ID, name, and email, are allowed, and the values have to be a certain type. For example, the email is not allowed to be a number; it has to be a string. So with this, you can like define object types. In other languages, oftentimes structs. And what you can do in TypeScript now with mapped types, you can map over an object type, and you can turn it into something else. So some of the built-in object types, map types into the TypeScript language, which are part of the TypeScript standard lib, but they're just implemented with the primitives that are accessible to everyone, are, for example, required, the required type or the optional type. So what it does, it goes through your object type, and it makes all the properties optional, or it makes all properties read-only or properties required. So with this, you can manipulate types, and you can take one type and turn it into something else. And how this map type is working, there's a loop defined in it, and that loop is oftentimes defined with a in statement, and you say you loop through something, through a list, for example, and before we dive deeper into like how map types, how you would do that in TypeScript, let's quickly go back into like our JavaScript mindset. If we now want to like build, if you want to loop like an object, oftentimes we need to do that. in JavaScript that we need to dynamically build up an object. We don't just get an object and return it or something like that. Let's say we have a bunch of entries, we have a bunch of key value pairs, and we need to turn that into an object. So what we do, we loop through the keys, right? And we take the keys, put them on the object, and then we give them a value, right? That's how we do it. And after all, we end up with an object, no matter what we use. For in, we can use or reduce. And this same thing is possible on a type system level in TypeScript. So you can loop again through something. What is the something in TypeScript? That's a union type. You can imagine a union type is a little bit like a list or like an array in JavaScript. So you can say it's either A, B, C, D, and it can be these 4 things, and you can now loop through them. So you can say the key in, and then this list of possible keys of anything, can be numbers, and then you can give them some value. You can look that value up somewhere. You can, for example, say, I picked this from this other type, or I want to wrap it in an array, whatever. And this way, you can like kind of dynamically in the type system define a loop that is running through the type that comes as an input. And this way you can turn any type into another type. You can do crazy stuff. And so what we are doing now, coming back to Prisma Client, that was a quick like excursus into more advanced TypeScript types. Prisma Client, why do we need something like that? And also, like, to the listeners who are not, like, we don't have any code here, right, that we are showing now on the podcast, but I still hope it's kind of understandable. So the idea is now in the map type, you give Prisma Client the object type that queries, let's say, ID and name. We loop through these keys, ID, name, and we now map that to a different type. So in Prisma Client as an input, we always get a Boolean. You just say ID true or ID false if you want it to be part of the payload, of the result. And we can now on a type system level check, is it the concrete Boolean true or false? And based on that, we can calculate the return type. And that is basically how all of this comes together. So again, when we were looking into that back in January, it was not clear at all, January 2019, it was not at all clear if this is even possible, because we did not see anyone out there doing it. And actually, I asked a bunch of questions in the issues in the TypeScript repo, and the answers rather sounded like, no, what you're doing here is stupid, don't do it. And we did it anyway. And actually, that's also what I mentioned in the talk at TSCon. For a long time, Prisma Client was not really type safe. There were edge cases when you were doing some like specific definitions of types that you could break the types basically, which we then also later could fix with some more TypeScript trickery. And what I really want to say here, I think TypeScript might be a bit scary. If I'm now talking about all of these crazy types, do I need to understand them to use TypeScript? No, not at all. And I rather think this is something that belongs into a library. This is not something I'm doing in my application code. If I'm writing an application, I've never used these kind of types. However, also yesterday at the meetup, you saw people, for example, implementing a game engine, game framework in TypeScript. These, if you are on that level, library level, there you can put a lot of complexity into it because it's like a surface, it's hidden, right? And I believe that with this, having the complexity rather in the library, we can keep our application code more simple.
Yeah, no, and so this, first of all, if you didn't understand what Tim just said, go and check out this generics, conditional types, and map types talk. I will put the link in the show notes so you can see this. And then also you're pushing the compiler to the limit. I'm sure you talk about a lot of it in there as well. But what you said, I'm going to boil this down quickly. Essentially what it is you can, in your query, when you write that query in in TypeScript, but you write that query just defined as a simple JavaScript object, that when that query returns this is at the type checking stage. This isn't even compiled. It actually generates a new type for you that shows you which items are available on the results of that query, which is crazy because I think about just defining an entity type, right? Let's say I'm just defining an entity type in a database, and I say, well, it's got an ID, it's got a name, it's got a date, it's got a client number or something like that. The problem is that if my query doesn't return all that data, then when I'm using TypeScript, it's going to say that it's there, even though it's not going to be there. And so this magic of saying we can dynamically generate types, so that even at the coding stage, when you're writing the code, that you know whether or not a certain thing is going to be available, that is just absolutely, to me, that just blows my mind. But you're totally right, though, because I think about sort of how I write TypeScript when I'm doing a simple project versus how I write TypeScript when I'm doing a library. And those are two very, very different things. And for me, I jumped into the library writing side of TypeScript very early. So I went down that rabbit hole, and I was like generics and all these map types and stuff like that. But the other thing I want to point out too is you mentioned these things as you were talking through. But this is another thing about that talk that I really appreciated, because it really helped me sort of connect TypeScript with a programming construct that I already understood. And that's when you compare JavaScript to TypeScript in terms of saying generics are like variables. You said this. Mapped types in TypeScript are very much so like loops in JavaScript. Union types are like lists. Conditional types were like if-else statements, and key of was like an object.keys where you could pull that out. And there's a whole bunch of other things too. I mean, even like never. Never was always one of those things I kept on seeing. I'm like, why? What's the point of never? But you're like, it's essentially a type error, right? And it's not always true. These things don't always hold true, but it is a really good way to sort of wrap your head around it.
Yeah, exactly. And I think that's really also the challenge in terms of education, that we can make this bridge between what is it in runtime, what is it in compile time. But I also see more and more people doing more advanced stuff here. And one of the advanced things that I just need to point out now, what came in TypeScript 4.1. So yesterday we had an engineer from Spotify. Actually, it was 2 days ago, from Spotify, also at the Advanced TypeScript meetup. And what he talked about is typed string template strings. So template strings, probably most people are familiar with that if they're doing JavaScript. Let's say a nicer way to concatenate or like have multi-line strings and all that kind of stuff, right? It was a great addition to the language. And now what they did in TypeScript, you can now type them. It's a bit insane. So in TypeScript, there's a keyword that is called the infer keyword. And what you basically do, you can define like a crazy type setup. You can say there's a promise and there's a function around it and 3 more functions around it. And you say in the third argument of the 5th function, you put the infer and then you just call it t, for example. And if the type that you got in has exactly that form of like 5 functions nested, then you can now take that type of that argument and you can do something with it. You can type check it, you can do certain things. And you can do the same with these template string types. So you can say that if there's, for example, a template string that has a specific structure, let's say it has so what they even did, they implemented a split, like a string.split on a type level. So you can say, I have, what is a split? You have a left side, you have a right side, and you need to have the split in the middle. So they just define that as a type, and you can do that in TypeScript now. And you can even make that dynamic what it's splitting on. So you can again have that as a type parameter. And so you can say now I have a left side and a right side. And what TypeScript is doing, it splits as soon as it finds that pattern. It's a little bit like how regex is working, like in a greedy fashion. And what you can then do, again, you can take what you split it, you can take the third part of it, like you split it into 3 parts. The first one, the middle, you may throw away in a normal split implementation. The third part, you again call split on it. So that's the powerful thing here. You can define a split function on a type level. What people even started with now is implementing a JSON parser in TypeScript on the type system level. So what does that mean? I have a string, and also important to understand why does this even work? In TypeScript, you not only have the string type, but you can also have a type that is a very specific string, literal, so that like the string with the specific content, that can also be a type. So you can say only the type ASD is possible. And if you now have a foo and bar, and if you have a union type between these, you can basically build your own enum. You can say it can either be foo or bar. So it can be the string called foo, with the concrete content foo, or the concrete content bar. And what you can do now, you can make these even more complex. You can do, you can also do union types of in the string template strings, which then distributes them. So you can do combinations and that kind of stuff. So people are still exploring where this is useful. I think where it gets useful is if, for example, in a timestamp API. So if, let's say, I am allowed to use the ISO, what is it, 8601 standard for timestamps. And you can obviously do a runtime check, but now with that you can actually do a compile time check if that string, that particular string that you passed in, is even valid. And what that parser is then doing, it's basically people implemented a regex on the type system level. So these kind of things, like, they are not making or breaking it, but like we get more and more these nice things to make the developer experience more awesome.
Yeah, that's amazing. All right, so a couple more things about TypeScript specifically, and then I want to bring it back to serverless for a minute. So with TypeScript, one of the, and maybe this is just a debate that I see because I'm reading all these different forums on Reddit and all kinds of things, but when you're building your types, when you're adding things like interfaces and types and things like that, how do you structure your documents? I mean, I know I have like multiple classes and things like that. Do you include interfaces and types? Do you put those in the same file? Do you separate them out into other files? How do you structure that TypeScript your TypeScript project, and where do you put those definition files?
That's a good question. So I have seen very different approaches for that as well. Some people put it in a types folder. So they have so in TypeScript there's something called definitely typed organization, and what it's basically doing, you mentioned earlier JavaScript libraries adding TypeScript support. It's also possible to do that outside. You can have a separate package that is then called with the convention add types / the module name, the npm package that you want to type, and that way you can put types on top of something that is untyped. This add types, calling a folder add types, that is a pattern that I have seen more and more often. So what people do, they have a separate folder with that kind of stuff, and then they just write down all the interfaces, all the types in that folder, and import that in their application. What we are mostly doing at Prisma still is keeping it simple and having the types collocated with the code. So that means the types are just at the head of the file, which is useful to understand the requirements that that function has. As soon as you don't have a simple, let's say, 2-argument function anymore, and you want to really have 5, 6, 7 arguments, it's useful to have an object as a input type. And there you will, especially also in React, you need to do it anyway. When you have prop types, you will just define that type at the top of it's quite useful, in my opinion, to have that at the top of the file. So you see the data requirements, what that function, what that class needs in order to run. So I think collocating it is one way I saw that, and also the add types directory. And then also, if you're writing TypeScript, oftentimes the code, like the types are embedded, right? I think this like location of types, we're mostly talking there about interfaces and like object types. But oftentimes you have the types embedded in your code if you write it in TypeScript upfront, so that you have your return type typed, or you have your parameters typed in there. So that's, I think, even more readable if possible. Yeah.
Awesome. Well, I am in the collocation camp. I love to collocate my types in the
Yeah.
files themselves. I just find it easier. The second you separate them out and you put them somewhere else, and then you have to go look them up. I mean, even if I have to import a type into a different file, I just import it. I just import the other file that has the type in it, and it seems to work pretty well for me. So I don't know if I'm doing it right, but it's good to hear that that you do a similar thing at Prisma.
Yeah, yes, exactly. And what I quickly wanted to mention here is that this really helps also us in the team as like communication. So what is really so we have ESLint rules activated. For the people who are familiar with ESLint, there was the effort of TSLint done by Palantir, and they merged that into ESLint, and now it's a plugin for ESLint because they just realized they cannot build such an awesome project again. So it's now like has access to the ESLint. AST and ESLint has the capability to pass TypeScript, and there are some rules that even force you to make the types a bit more explicit, and that helps us in the team. In the moment that you are writing the types, especially coming from the front end, or like in general, I see that a lot with front end developers. Types are in their way, or it feels like I don't want to write this type. Why do I even need this? I have the feeling the acceptance for this and backend and Node.js is a bit higher still, because also to be fair, the React tooling and so on, it's already quite awesome. And ESLint is already nearly, you could nearly call it TypeScript compiler because it already does, it understands the code already quite deeply. But anyway, we have a rule in our setup that forces you to explicitly write down the return types. And why is that interesting? For you in that moment, it's trivial. You just hover with your mouse and you see it's whatever the TypeScript language service in VS Code will tell you this is a number. Where this is really useful is for the PRs. So if you have the PR review in the GitHub UI, you don't have your your IntelliSense. In that case, the types are really useful to just understand what's the contract. After all, a type system is a contract, right? What gets in, what gets out. And also then later, if you are refactoring and you are not aware what was the type actually, and you think you didn't break anything, with having the return type explicit, you just know what is expected of this function. And we found that quite useful.
Yeah. And the other thing too that's great, besides ESLint, is just Jest. I use Jest for all my unit testing, and with the TypeScript support there, it just works really, really well. So, all right, let's bring it back to serverless, and then I'll let you go and get back to your TypeScripting. The cloud edge, right, or edge computing seems to be something that is getting more and more popular. And we've got Fastly and Cloudflare Workers and things like that. And so I know a lot of them run on the V8 engine, right? But there's also all this stuff with AssemblyScript and WASM. Like, what are your thoughts on that?
Yeah, that's really interesting to see. I mean, if we talk serverless, oftentimes it seems like serverless equals AWS, but I have the feeling that is changing more and more. I mean, I think Cloudflare can now be considered a legitimate player on the market in serverless with Cloudflare Workers. And it's also really interesting to see how Fastly and Cloudflare are targeting completely different markets. Cloudflare is rather going for the application developers. They make it easy. They give you JavaScript. They made the V8 engine very fast. So they did some tricks to basically give you nearly zero cold start. So what they did is that while you have a TLS handshake, they already boot the function for you. And as they have this very minimal V8 runtime, it's much faster than if you have a Lambda function that now needs to start the whole thing. And this way you have much more lightweight functions. They are not that, they cannot do that many things. You cannot run native code in there. However, let's say the gate into native code is WASM, WebAssembly. Also crazy news that Fastly basically hired basically all the WASM people from Mozilla.
Right, I saw that.
So like either if you're a Rust developer, it seems like either you're like working for Fastly or I don't know, then it's like long tail. So they have extreme competence now in that team. And for Fastly, it seems rather they are going for the advanced use case. I mean, that's the whole Fastly CDN is built in that direction, right? That let's say TikTok is using it, for example, or Stripe. You can do these crazy configurations. It's not necessarily built for application developers. However, in order to get into their runtime, so we just talked about the Cloudflare runtime, which is based on V8. You can just deploy JavaScript and that's it, which then also, by the way, means that you can deploy TypeScript. And there are great examples out there how you can run that. In Fastly, you can also theoretically do TypeScript, but rather a subset of it called AssemblyScript. So they are pushing it really hard. They are also sponsoring the AssemblyScript project. And what is AssemblyScript? So the idea is really they selected a subset of TypeScript. It's the same syntax. You feel familiar with it if you use it. That is able to compile to assembly, WebAssembly. And so the Fastly runtime is a different beast than it's a completely different design than Cloudflare. They claim, I think they have 34 microseconds boot up for the runtime. Right. So if you give them your WebAssembly file, then they can boot that on the edge in 34 microseconds, which is impressive. And this now allows you to write, and that is traditionally only Rust. Also, their first tool chain, what they are supporting there in the Edge beta, I had a look at that. It's only Rust. However, now they're adding the AssemblyScript support, which is exciting because this opens up this extreme, let's say, advanced edge computing, which normally if you are, let's say, solo developer, small team, you would never look into that. Now you suddenly have access to that, and you can write very fast edge functions. So the difference with between Fastly and Cloudflare there also a bit, because I looked into that quite a bit because I'm working on a side project related to that. In Cloudflare, the function, it's not a Lambda function, but it's a function. It's always triggered. So that's basically the outer edge. Even before the cache is hit, that function is always called. And then in that function, you have access to the cache API and can get something out of the cache and return it. So the cache that is basically powering Cloudflare. In Fastly, it's different. Fastly has Varnish in front of everything. Which is this quite old cache implementation, but very legit and just works well. And you can now talk to Varnish, you can communicate, you can configure Varnish on top. And then if Varnish didn't have the cache, then you can have, you can write your function behind that. And that can now also be with AssemblyScript, basically TypeScript. But I have to be fair here, it's not really yet TypeScript. Most of the packages will not work. I had a look into it. It's not yet there. It will take a while. Yes, it has the same syntax, but there is still a way to go. If I would use WebAssembly at the edge, I would probably rather do Rust today because the tooling there is much more advanced. But it's still really exciting to see that they are pushing forward this. And Cloudflare, I think, is a great addition as well. And I am actually using it as a cheap alternative to API Gateway. Because you have pricing of like 50 cents per dollar per million requests. I think API Gateway you're somewhere at $2.50 or something to $2.50.
I think it's $3.50 for the rest and $1 for the HTTP APIs. If that's not confusing enough.
Yeah, exactly. And now you are down to 50 cents basically with Cloudflare, because what you can do, there are packages out there that you can directly call your Lambda function with AWS API from Cloudflare, from a Cloudflare function. So you can now have that as your gateway, which is really exciting. And again, all of that can be type safe if you write it in TypeScript. Yeah.
That's amazing. Yeah, no, I think the whole WebAssembly thing and and edge computing, that to me is this next evolution of serverless computing. I mean, the idea and what's great about the WebAssembly too is that, again, running that on a browser, right? There's so many more things that you can do there and package so much more compute there. And so the less that less that the internet is required here to connect to a little bit of data. But again, everything powered in that toolchain is just absolutely amazing. So
Really exciting stuff. Tim, thank you so much for sharing your knowledge here, because honestly, I've learned so much from you just through the video that you did in our previous conversation. So I am very, very happy that I found you, because it completely opened or changed the way I think about TypeScript. So I appreciate that. I hope this did something similar for people listening to this. I will put all of your talks in the show notes. But if people do want to get a hold of you, what's the best way for them to do that?
I guess just on Twitter /Tim Suchanek. I guess in the show notes maybe there you can link to it, but it's just TimSuchanek. It's the name comes from Czech Republic. No, my heritage is German, but yeah, that's where it originally comes from. Yeah. Anyway.
Awesome. And then if people want to check out Prisma, they go to github.com/Prisma, correct?
Yes, or prisma.io, exactly.
Awesome.
So the Prisma client is out there. They can check it out. It always also works for JavaScript, and we have a Go client in beta, so you can also check that one out. Yeah.
Awesome. All right. I will get all that stuff into the show notes. Thanks again, Tim.
Thanks for having me.
And that's this week's Serverless Chat. I want to give a huge thank you to Tim Suchanek for being my guest this week, and to our sponsor, Epsagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/83. For more Serverless Chat, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter @Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.